All right. So we are going to do the quotient rule. So quotient rule is used to efficiently differentiate functions that are ratios of two functions. So when you say two functions, it means whatever will be here at the top is a function, and then also at the bottom is a function. So when you differentiate this function, you're going to say the derivative of ux. Please mute your mic. You're going to say the derivative of ux times the function of v minus the function of u times the derivative of v, then over the the function of v squared. So I'm going to make an example so that you can understand. Please remember that when we differentiate, you say if you're differentiating x to the power of n, you're going to say you take this n, then you say x to the power of n minus 1. You multiply by n on the side, and then you minus 1. You minus 1 from n. So you're going to follow this rule of quotient rule. So we are going to firstly name our ux. So we are going to say the function of u. The function of ux, I am going to say this is my ux. Let me use red. So I'm going to say my ux is going to be my numerator, which is x to the power of 3. And then I differentiate ux. When I differentiate ux, it's going to be the derivative of u. You say 3 times. So when you derive, it's going to be the 3 because your n is 3. You follow this rule. So it's going to be, we're going to follow this rule. So we're going to say 3, then x to the power of 3 minus 1, which is 2. 3 minus 1, it's 2. All right. Sorry, excuse me. All right. So it's going to be 3x to the power of 2. And then now we say Vx, our Vx. So we're going to say whatever is at the bottom here is our Vx. So Vx is 1 minus x squared. When you differentiate this will be the derivative of 1 is 0, and then minus, then 2, then x, then 2 minus 1 is 1. Again, I repeat, I'm using this rule of saying you take the 2, you put it here, then you minus 1 from that 2. So that's why I have negative 2 x to the power of 1. The derivative of a constant is 0. Derivative of 1 is 0. Derivative of 2 is 0. All right? And then after this, now I'm going to derive now. So I have my functions derived. So I'm going to follow the rule. The rule says that when you are deriving a ratio, so this will be derivative of this will be equals to the derivative of u times the derivative, sorry, times v, not the derivative of v, times the function of v, and then minus, I'm following this, then this will be ux, and then times the derivative of vx. I'm just rewriting the rule. Then everything over vx squared. We square the function of v. Then now we substitute. Your ux is going to be x squared. This will be x cubed, not x squared. X cubed, bracket. And then now the vx is 1 minus x squared.
I'm sorry, ma'am.
Yes.
It's not x cubed, definitely x squared because it's the derivative of
It's not the derivative. Oh, sorry. It is the derivative. Sorry. sorry, Vx is the one that, yeah, sorry, it is the derivative. So this is 3x squared. Thank you. And then minus, and then ux is not the derivative. So this will be our ux is x to the power of 3 in bracket. And then the derivative of v, sorry, the derivative of v will be negative 2 x to the power of 1 because 0 is 0 minus 2x is it's negative 2x. And then everything over. And then now we square the v, function of v,
Sorry, ma'am.
1 minus x squared. Can I finish first? And then you'll ask, unless if you're correcting me. Can I finish first? Then you'll ask me.
I was asking that one for open brackets minus 2x to the power of 1. Is it important that we have to write to the power of 1? If you don't write it, we will lose a mark.
No, it's still fine. You're not going to lose a mark.
Okay, thank you.
Okay. And then now we multiply. So when you multiply here, you're going to distribute. You're going to say this times this. And then you'll see that here, I showed you that when we are adding, we say 2 plus 5. Then the only thing that changes is the quotient, the coefficient, the x squared doesn't change. And then here I showed you that when you're multiplying, you multiply the number with the number, and then you multiply the x with the x. So this will be 2 times 5, it's 10. X to the power of 2 times x to the power of 2 is x to the power of 4. So both the coefficient and the exponent, they change. So I was doing it so that you can understand how I get the answers here. So you distribute this, when I say 3x squared times 1, it's going to be 3x squared. And then you say 3x squared times. So you distribute, you also multiply again with x squared. You're going to get a negative, and then it's going to be 3. Then x to the power of 4, because when you're multiplying, the exponent changes. So it's going to be x to the power of 4. And then now we come to this one. So this is a minus, and then you multiply these two together. The answer will be negative, then 2, then x to the power of 3, because x to the power of, x to the power of, x to the power of 3 times x to the power of 1 is going to give you x to the power of 4. Sorry, forgot to square this one. And then this stays the same, it's 1 minus x squared, and then to the power of 2. And then now I am going to multiply this negative with this negative. Then I am going to have 3x squared minus 3x to the power of 4. Negative times negative is a positive. Then 2x to the power of 4. And then after you multiply, we add like terms. You add bananas with bananas. Every time you multiply, after multiplying, you add like terms. Now, the only two terms that are the same is the ones that have the same power. This and this one, they are the same because they have x to the power of 4, x to the power of 4. So my final answer is going to be 3x squared. There's no number with a square. When you're adding, you must add the ones that have the same exponent. Variables that have the same exponent, you can only add. So these two, they have the same, x to the power of 4, x to the power of 4. So I'm going to say minus 3 plus 2, I am going to get a negative. Then this is 1x to the power of 4. You don't need to write the 1. I'm just writing it so that you can understand. Then this whole thing over 1 minus x to the power of 2, then squared. And then that's our final answer. You don't have to write this 1x to the power of 4. Now I can take a question. Is there a question here before I continue? Excuse
Ma'am,
me.
can I ask
Yes.
again a question? So do you see there where you said minus open bracket x to the power of 3, close bracket, open bracket minus 2x to the power of 1, close bracket, right? So I don't know, maybe in my understanding, because I did pure maths, right? Don't we have to close the first bracket of everything before we change it to that minus open bracket minus 2x to the power 4, ma'am?
You mean here?
No. Here, you see the second step after you put it the dy over dx? Yeah,
This one?
yeah,
Yes.
after the minus. I thought maybe there's gonna be a bracket, not
Yeah,
just
they
yeah.
it's because of I have two functions. Remember, I have x to the power of 3. It's a function on its own. And then I have negative 2 x to the power of 1 is a function. So I still have my brackets before the negative.
Oh, okay. I thought maybe you're gonna put a bracket from the beginning and then also again with those ones. That's what my
Oh,
oh
okay.
yeah.
But it's the same thing. It doesn't really matter. You can still do
Okay.
that, but it doesn't really change anything here.
Okay. Thank you so much, ma'am.
All right. I saw a hand.
Ma'am, hello,
Yes.
ma'am.
Yes.
I wanted to ask, I see on the step that she was talking about, the x to the power of 3 into negative 2x.
Mm-hmm.
Why does the power become 4 at the next step?
X to the power of 3 times x to the power of 1. When you multiply, you add the exponents. Every time you multiply the variables, you add the exponents. The exponent here is 1. So x to the power of 3 times x to the power of 1 is going to be x to the power of 3 plus 1. When you're multiplying, it's like you're counting. So you're going to have 4 x's.
Okay.
If you can see, that's what I did here when I was doing this one. But I did this one. That's why I wrote this as an example here, so that you understand that x to the power of 2 times x to the power of 2 is going to be x to the power of 4.
Okay.
Yes. All right. Yes. Yeah, I saw a hand. You can continue. Ask the question.
Ma'am, with the formulas that you just gave us, ne, the two formulas, can you please go on top?
This one's.
Can we use either of the two?
Yes, out of the
Okay.
two. It's
Okay.
the same thing. Yes.
Okay.
Yes. Next question.
Um,
I'm listening.
Sorry, ma'am.
Yes.
And I think maybe that will make our life easy. Where you say you must remember. In mathematics, we say if you multiply, like we make that two example. If you multiply, you add both exponent and the base. That way you have 2x squared multiplied by 5x squared, you have a 10 because you add both exponent and the base. But if you add it, you only add it to your base, not to exponent. That's why it remains 2 plus 5 is equal to 7x squared. But if you add, you only add the base, not the exponent. But if you multiply, you add both exponent and the base. If you can put that in our mind, it will make our life somehow much more easier. Yes, for those 2 years. If you
Okay.
add, you can understand how to differentiate. Just how to differentiate them. You add, you just add the base, leave the exponent as they are. They don't change. But if you multiply, you change both of them. That's why you have 10 to the power of 4. If you multiply, if you can just make it like that.
Yes, you also add the exponent. Yes.
Yes. So if they
Oh,
can put it like that, then it will be golden rule.
yes. Thank you. All right. Let me do another one so that it can make sense.
So
Yes.
Masoko, before you move on, that one x to the power of 4 at the final answer, the nominator, where did you get that?
Minus 3 plus 2. These two are like terms. They both have x to the power of 4. That's why I wrote this here. You can only add the ones that have the same variable with the same exponent. So negative 3 plus 2 is 1. Do you understand? These two are like terms. They're the same, both bananas, because they have x to the power of 4. So you just add negative 3 and positive 2. You say minus 3 plus 2. It's going to give you a negative 1 with the calculator. All right.
Okay, ma'am, I was asking, or when you're done, can you please just attach this like last week?
Yes, I'll do that. Thank you. I will attach
Thank
this
you.
also. Yes, it will be under
Especially
lessons. It's going to be under lessons. Where your video is at, you'll see under documents. for lesson, I think this is part of lesson 4 or 5. You'll find this document there. All right.
Yes, also integration, ma'am. You see these kind of difficult topics. We need this. We need them here.
Okay, no, I'll do
Thank
that.
you.
All right, let's go to B. Can we go to B?
Okay.
Yes, let's go to B and then you'll ask when I'm at B also. Let me do it again. So we said that you need your UX. We start with, please mute your mic. Please mute your mic. We start with UX. So I'm going to say UX is the one at the top, which is lean X. Every time the one at the top is U, it's up to you how you want to do this. And then, sorry. And in this one, then I'm going to derive this one. We said that, you see, I wrote here, remember. So I'm writing this so that you can remember, even if you didn't attend last week's class, you can understand how we get this. So to differentiate a lean anything, is going to be 1 over whatever is next to this. We call it lean. We pronounce it as lean. This in is lean. Just say lean. And then we derive. So I'm going to derive this. So u prime x is going to be equals to 1 over x. And then now I'm going to differentiate. Now this one at the bottom, I'm going to call it a vx. So this will be a v. X is going to be this denominator, which is x. And then now we differentiate this v. So this will be the derivative of x is 1. The derivative of any variable is 1. So how do we get that? You say there's always a 1 here. So it's 1 times, so this is 1, then x to the power of 1 minus this 1. I hope you can hear that, child. Then this is x to the power of 0, which is going to give me 1 because 1 minus 1 is 0. Any number to the power of 0 is 1. So now I have my derivatives and my functions. Now I'm going to go back to the formula. The formula says that if you are deriving y, the derivative of y with respect to x is going to be equals to my ux. It's what derivative of u, ne? Jesus. The derivative of u times vx, then minus the derivative of, no, not derivative, then minus ux times the derivative of vx, then it's over vx squared. So we square that. Then now I'm going to substitute. So this will be, create the space. So this is going to be, my ux is lean, so I'm going to just say this is lean x in brackets. And then times my Vx.
Ma'am,
Yes, can I finish first? Can I finish first? Unless if you're correcting me. If you're
I
correcting
saw
me, you can
you
go ahead, but sorry?
you're writing in X.
Oh,
Writing in X is
yes. Oh, yes. Thank you. Yes, I wrote lean X again. Thank you. All right. Then this times Vx is X. So this is X. And then minus, minus. And then now my Ux. My UX is lean X. Lean X. And then my derivative of V is 1. So this is 1. And then over V. Our V is X, so we're going to square it. X. Then we square. And then now we can solve 1 over X times X is 1, ne? 1 over X times an X. The answer is 1. Why? Because these two are cancelling. It's 1. So I will have 1. I will have 1 And then this times this is just the negative ln x. And then over x squared. That's how we do this one. Yes, questions? Questions?
Hello, ma'am.
Yes.
Okay, if, for example, we have 1 over x times x to the power of 2, how do they cancel out?
If you do what?
Let's say maybe we're deriving, and then we have 1 over x times x squared. How do you get the answer?
X squared, it means how many x's do you have?
2.
2. So it means that the 1 will cancel the 1. How many x's will be left?
1.
Thank you. So you'll have x.
All right, thank you, ma'am.
All right. And then now we move on to C. C, I'm going to do the same thing again. So here I'm saying remember, because we did this last week. So I'm saying remember that the derivative of e to the power of x, it remains the same. It's just e to the power of x. So we're going to follow the rule again. We're going to start with the ux. Our ux is going to be x squared. Whatever is at the top is our ux. Then now we derive. When we derive the ux, it's going to be 2 times x to the power of 2 minus 1 is 1. Again, I'm using this rule. Let me just do it here. If I have to derive x squared, this is what I did so that you understand. X to the power of 2. When we derive, the derivative of x to the power of 2 is going to be 2, then x to the power of 2 minus 1. Then that's why the answer is 2x. Hence, I wrote the 2x to the power of 1. You don't have to write to the power of 1. And then now we're going to v. V is your denominator. My denominator, so vx, I have 1 plus e to the power of x. Then now when I derive, then this will be, the derivative of 1 is 0. Then plus, I said that the derivative of e to the power of x is e to the power of x. It doesn't change. And then now we're going to write the formula. The formula says, the formula says that the derivative of your function y is going to be equals to the derivative of u, and then times vx, then minus ux times the derivative of vx, and then over vx then squared. We square the derivative, the function of vx. Then now we're going to substitute. The derivative of u is 2x, so we are going to say 2x. So this will be in brackets, 2x, and then vx, our vx is 1 plus e to the power of x, and then minus minus. And then now we say ux, our ux is x squared. So this is x squared. And then times our derivative of vx is e to the power of x, because 0 plus e to the power of x is just e to the power of x. And then now everything over the vx, we square it. Our vx is 1 plus e to the power of x. So this is just going to be 1 plus e to the power of x, all squared. And then now we are going to multiply. Every time you multiply before you add the like terms. So we are going to multiply. So because I'm multiplying 2x times 1 plus e in brackets, I'm going to distribute. So I'm going to say 2 times x. So 2x times 1, it's 2x. And then 2x times e to the power of x is just going to be 2x. And then e to the power of x. Oh, this is plus, sorry. So this is going to be plus just 2x, then e to the power of x. And then minus, just going to be minus here because these are not two numbers. This times this is just going to stay the same. It's just going to be x squared and then e to the power of x. And then everything over 1 plus e to the power of x all squared. You cannot add. These two are not like terms. Your 2x e to the power of x and x squared e to, they're not like terms. So your answer, this is your final answer. Questions? This is your final answer? I saw a hand before I finished. Yes. Yes, Tobani.
Hi, ma'am.
Yes, hello.
Oh, sorry for disturbing or taking you back. The thing is that Friday, ne, our class were clashed with a FAC, ne? So I didn't attend this one. So I just wanted to know, ne, I see you doing the derivative, ne? There is this I'm coming to number C, ne?
Yes.
The formula is y is equal to x squared over 1 plus ex, ne?
E to the power of x, not ex.
Oh, okay, sorry.
It's an
I just
exponent. Yes.
to be clarified with this one, it is the dy over dx. Well, the time you are doing the derivative, what is that formula? Is uf? Is u? Can you just say it again? This formula, y, the derivative one.
This one is a quotient rule. Yes, the one. The derivative of a function is equal to the derivative. If you are given, I'm saying the quotient rule is used to efficiently differentiate functions that are ratios of two. So meaning that they are fractions. Two
Yes,
functions that are a fraction. Yes. So this is the formula. You have to find the derivative of both of them. Then you substitute. It's going to be the derivative of u times the function of vx minus the function of u times the derivative of vx over the function of vx to the power of 2.
Okay, I got you. Okay.
Switch off the mic. Mute your mic. All right.
Okay.
So I will always take you there. That's why I always write these so that you can see. All right?
Okay. Okay.
Yes.
Can you come them to C number C, ne? With the substitution, ne? Okay, we said now we derive 2x squared is x squared, ne? You see
Yes.
number y is equal to x squared over 1 over e exponent x, ne? We derive first before we substitute, ne?
Mm-hmm.
We said, okay, it's 2x. Okay, we multiplied that exponent 2 with the coefficient of x. So we got 2x. Yeah, I saw
I
that.
wrote it here. Yes.
Oh, okay, let's come to the step number 2. The substitution is 2x into 1 plus e. It's, what do you call this one?
E to the power of x. E exponent x.
Okay, this one. Okay, okay, thank you so much, man. I get you now.
Is it final?
Yeah. I'm gonna watch the videos again if I didn't call you. Thank you so much.
Okay.
Sorry, ma'am.
Yes.
Can you please go to your first step, like can you give me the A, B, C? I wanna take the screenshots and then you can continue.
Oh, okay.
Late. Thank you.
All right.
From the A.
Oh, from A. Sorry.
Yes.
From A. Okay. Should I? Okay. Let me put it like this. Then I'll move it up. Or should I include the notes also? Is it fine? Or should I start here?
No, but ma'am is gonna upload it on our modules.
Yes. Yes, I'm gonna put it there. Yes, the whole document. I'll put the way it is. I'm not gonna edit anything so that you remember what we're doing.
Okay, you can continue. Fine.
All right. Yes.
I've got a question.
Yes.
Just here to see. I just wanted to ask, do we always leave our denominator like that? Because I think I don't know. I didn't do maths. I didn't do maths at school, but I think we can still simplify that. So we don't simplify, we leave it as it is.
You will leave it as it is. It cannot be simplified. Even if you multiply your denominator, you're not going to be able to cancel. So in maths, for you to be able to cancel this denominator, you're going to have to factorize the numerator. And there's no factorizing this one. You cannot factorize the numerator. Do you understand?
Oh, so we leave
We leave
that
it like
exponent
this.
that exponent 2 like that as it is.
Yes, yes.
Okay.
According to the rules of maths, we can't unless if we factorize the numerator. So we just leave it as it is. All right. And then now we go to this one. Okay. So now we go to this one. I don't know why do I have so much space. Okay. All right. So now we go to what we call the higher derivatives. So the higher derivatives they're saying the higher order derivatives are used to determine and or confirm maximum, minimum, and inflection points. So you'll understand this statement as I move on. But then when we talk about the higher derivatives, you are differentiating the first time, the second time, and the third time for you to be able to get the maximum, the minimum, and point of inflection. So remember, the whole point of this is for us to maximize profit and minimize the costs. So I'm going to teach you how to derive. The first time, you know how to derive for the first time. And then we have the derivative for the second time and the third time. So here they're saying, find the first and second derivative of the following function. So we are going to derive. Nothing has changed. We still apply the same thing. I said to you that when you derive, you say, if you are given the function, if they say your function is y is equals to x to the power of n, when you derive, I'm just doing this so that you can understand. When you derive, you're going to say the derivative of my function y over dx is equals to this n. I'm just going to do this so that we understand. And then we say x, and then you say to the power of n minus 1. That's what you do, n being any number. So I'm going to do it again. So this is just the rule of differentiation. When you derive using the power rule, that's what we always use anyway to derive. This is the basic step. You say the exponent, then x, then n to the power of 1. That exponent minus 1. Every time you minus the 1. So now let's derive for the first time. So the derivative of this one for the first time is going to be the derivative of y for the first time over dx is going to be equals to. So remember, this will be 10 because it's times 1. There's a 1 here, but we never write it. There's always a 1 there. So this will be 10. Those who were here last time, you remember, it's just times 1. You don't have to write this step. I'm just writing it so that you can understand. This is x to the power of 1 minus 1. And then plus, then it's 0.5. And then x, and then to the power of 0.5 minus 1. You always minus the 1. Again, I'm just doing this so that you can understand. Then this is equals to 10x to the power of 0, and then plus 0.5. You can also write the half if you want. You can write it in a fraction form. This is x to the power of 0.5 minus going to be negative 0.5. You can also write it as a fraction. I repeat. And then x to the power of 0 is 1. So this is just going to be 10. And then plus 0.5 x, then to the power of negative 0.5. You can write this as a fraction. It's still fine. You can say 10 plus 1 over 2, x to the power of negative 1 over 2. It's okay. It's the same thing. And then now we derive for the second time. So this is the first derivative. When you derive for the second time, you take the answer that you got on your first derivative. So this is my answer. I'm going to take that answer. So this will be, now I'm deriving for the second time. So this will be d squared because I'm deriving for the second time. Then x squared. I'm deriving y. Not y, I'm deriving this one, sorry. I'm deriving the answer that I got, which is 10 plus 0.5 and then x to the power of negative 0.5. Or I can just say y actually, the second derivative. Sorry, let me write just y. There's no need to do this. So this is still y, nothing has changed. So I'm deriving for the second time. So I'm going to take my answer that I got here and then I derive. The derivative of 10 is 0 because 10 is a constant. So this will be 0 plus. And then now we are deriving this one. When you derive this one, it's going to be 0.5 times this negative 0.5 x. And then to the power of negative 0.5 minus 1 every time you minus the 1. And then now we answer. We said with these rules, there are two rules. If I have a constant, let me write it so that you can understand again. If your y is equals to a number, maybe let's say k, then x to the power of n. When you derive it, it's going to be dy over dx is equals to k times n. Nothing has changed. You still write the n, the exponent. So whatever was next to x, you multiply it with the n. And then this will be x to the power of n minus 1. Nothing has changed. X to the power of n minus 1. This is what we did last time, n minus 1. So that's what I'm using here. That's what I'm using here to do the blue one. I said 0.5 because I already had the 0.5 times this negative 0.5 and then x to the power of negative 0.5 minus 1. So I will have here, because 0 is just 0 here. So I'm just going to have 0.5 times 0, negative 0.5. I know it's 1 over 4. What is 1 over 4 in a decimal form? 0.25. So this will be negative 0.25. And then x to the power of negative, no, it's a 3 over 2. So what is 3 over 2 in a decimal form? 1.5. 1.5. Again, if you write it in a fraction form, it's still fine. It's not wrong. It's still okay. Like you haven't done anything wrong. Then now I'm moving on to the third derivative. So third derivative, it means going to be d to the power of 3 now. It's the third derivative. So I am going to have d to the power of 3 over dx to the power of 3. I'm still deriving y. But I'm going to take this answer now. I'm deriving what I got here. So I'm going to derive this answer. When I derive this answer, it's going to be negative 0.25 times negative 1.5. I'm applying what? I'm applying this one here. So this will be then x, then to the power of negative 1 over 5 minus 1.5 minus 1. You always minus the 1. Then my answer here is going to be a positive. So 0.25 times negative 1.5.
0.375.
0.375. And then x to the power of 2. Is it 2?
Negative 2.
Negative 2. Negative 2.5.
2.5.
Yes. I repeat, even if you write it in a fraction form, it's fine. It always depends on your options when you're writing your assignment. So this is how we derive. First derivative, second derivative, then the third derivative. Questions? Let me do it again before you ask me another question. Can I do it again so that you can understand without these decimals? Let me do it again before you ask a question. Can I do it again so that you understand? I am going to do it again. I'm going to call this B. So
Sorry,
let's say, for an example, yes.
Sorry, before you do it again, on that red line, ne, where our answer was 10 plus 0, x, what happened to that x, the previous x of 10?
What is x to the power of 0?
Oh, okay.
1.
Any number, yes, any number to the power of 0 is 1. Any number to the power of 0 is 1. So x to the power of 0 is
So
1.
is that, excuse me, teacher, sorry, interrupt you. So is every power 0 is 1, right?
It's what?
So the powers of the 0 is 1, right?
The power of 0 is 1.
Yeah.
No.
Right.
X to the power of 0 is 1. Any number to the power of 0 is 1.
Okay.
10 to
Yeah,
the
okay.
power of 0
0 is 1. Okay.
is also 1. Yes.
Right.
Any
Okay,
number
thank
to
you
the
so
power of
much.
0 is 1.
Yes.
Yes.
Okay. So any 0, okay, is 1. Okay, thank you.
Oh, all right. Okay, can I do another one so that you can see? This one has a lot of decimals, so it might be confusing. So I'm going to do it again. First derivative, second derivative, and then third. Can I do the example and then you'll ask questions after? Can I do this example with a whole number, with an integer, not a whole number, integer? So I'm going to do this example. First derivative, the first derivative of this one, so it's going to be dy over dx. Let me write my y in black. I am deriving my y for the first time. Even if you write f, it's fine. You don't have to write the y. You don't have to write the dy dx. Sorry. So I am going to derive. When I derive, I said that I'm going to do it the longest way so that you understand. I said it's going to be 3 times x. That's how we derive. Then to the power of 3 minus 1. N minus 1. This is going to be 3x squared. And then now we derive for the second time. When we derive for the second time, it's a square now. It's going to be d squared over dx squared. Of what? Of y. We are deriving for the second time. You take your answer here. Then you derive it. When you derive, this is going to be 3 times 2. And then x to the power of 2 minus 1. And then this is 3 times 2, it's 6. Then x to the power of 1. And then now we derive for the third time. So it's going to be d cubed or d to the power of 3. So this will be d to the power of 3 and then dx cubed of what? Of y. Sorry, let me use the paper one just for consistency. So this will be d cubed over dx cubed of y is going to be, you take this, you derive it, your answer there. So this will be 6, then times 1, then x to the power of 1 minus 1. And then this will be 6, then x to the power of 0. And I said that any number to the power of 0 is 1. So this will be just 6 times 1, which is 6. Now you can ask the question. That's what I wanted to show you because this one is a decimal, so it looks funny. But now if it's a whole number in integer, it can make sense.
Okay, quick one. How
Yes.
would the question come out in examination? How would they phrase it to say you need to derive first time, second time, third time?
Here it is. Find the first and the second derivative of the following functions.
Okay.
Yes. So you know that you derive after you get, if they say derive it first and second, you take your answer and derive the answer. If you can see, I was deriving this answer here.
Okay, all right, perfect. And would we ever be expected to graph it, the minimum point,
No.
maximum point, inflection? No.
No, no.
Okay, thanks.
You just need to know how to find them. That's all. Finding the point of inflection and the maximum and the minimum. So this is going to help us. Knowing how to derive the first and the second time is going to lead us to knowing how to optimize minimum, maximum. So this is just the basic to introduce us to this one, optimization of functions, maximum and minimum points, minimum turning point, sorry, yes. Yes, questions?
So, ma'am, those are derivative squared cubed. They literally have no impact on the equations.
No, I said you can write this. If you want, you can say f of x. This is first derivative. Second derivative is it's prime prime. Third derivative is f prime prime prime. It's either you use the d's or you use the f. It doesn't really matter. Someone can also say a y derivative, first derivative, second derivative, third derivative. That's it. And remember, your assessment is a multiple choice. But again, if whether you use the F, you use the Y, it's still okay in your case because we're doing this under economics. The most important part is we want to focus on maximizing and minimizing profit. Yes, Tato? I think I see three hands there. Yes.
Can you hear me, ma'am?
Yes, I can hear you.
Ma'am, the question said first and second derivative. Do you
Oh,
include the third
sorry.
one?
Oh, sorry. I included the third one. Sorry, I just wanted to do this. The third derivative as case, yes. Let me
Thanks.
include the third one, yes. Thank you. Let me include the third one. I just did this because I wanted to show you the first, second, and third. Let me just say and third. Yes, thank you, Tato. I missed that one, eh? Yes. Yeah, first, second, and third derivatives. Yes, thank you. Yeah. So I did it 3 times. Did it the first time, the second time, yes. Yes, Grace can ask.
Oh, ma'am, we don't need to go further than the third derivative, right?
No.
Okay.
It ends. We always gonna use the first and the second in most cases. The
Oh.
third, it's point of inflection, yes. But I don't think you do look for that one because we are not drawing a graph.
Oh.
But it's always 1, 2, 3, yeah. 1, 2 in most cases. Yes, Ngoni.
Hi, ma'am. So when we defined higher derivatives, we said we calculate them to confirm minimum, maximum, and point of inflection. So from the answers that we've got, how then would you
Yes, that's where I'm going. That's why I'm saying the higher order derivatives are used to determine and or confirm maximum minimum. So you can see the question didn't say anything about the maximum and the minimum. So I am going there. That's why I said this is the basic. I'm introducing you to this one now. That's what we're going to be doing now. So you need the basics of deriving the first time and the second time. If I say derive first and second, you derive your answer. You derive your y. After that, you take the answer and derive it. Take the answer and derive. That's what I wanted you to get. All right. Now let's go to optimization of functions in one variable so that we can see what we're doing here. So optimization of a function in one variable is about finding the maximum or minimum value of a function. Yes. Yes.
I wanted to ask before you continue with the steps. In that question of deriving the second one, can you please go back and I want to ask a question in regards
Okay.
of. Okay, you see the second step of deriving, right? You see, you said we take the answer that 10, right? And we derive it on the second. So the question is, ma'am, I thought maybe you're gonna start with that minus 0,5 and times it with a 0,5 because the x is the second, the way you derive it in the x part from the beginning of derivation.
Are you talking about this one?
Yes, ma'am. You see there by the end, the first time you derive, right? You see that minus 0,5, right? I thought when you derive for the second part, you see there after the plus 0 plus open bracket.
It's
I thought
here.
maybe
Here it is. Here it
yeah, I
is.
thought maybe you're gonna start by minus 0,5, right? Times
Oh, it doesn't really matter. It
okay.
doesn't really matter. Yes. If you say negative 0,5 times 0,5, it's the same thing.
Okay.
Yes,
Okay.
it doesn't really matter. Yes.
Okay. Thank you.
Okay. Yes.
Sorry,
All
ma'am.
right.
On the next step after that, I think the answer is 10, but you wrote 0. I was asking myself where you got the 0.
I'm deriving. What is the derivative of 10?
It's
What
zilch.
is it? What is the derivative of 10?
0.
It's 0.
Yeah, it's not.
Derivative of 10 is 0. I'm already deriving here. I didn't rewrite this. I'm deriving. That's why I said 0,5 times negative 0,5. I am already deriving.
Sorry,
You
ma'am.
derive the 10, you derive the 0,5. Yes?
On that point, to prevent confusion, because there is slightly confusion, how about the answer that you got it first? Write it down as it is before you derive it. So I can little bit prevent the confusion. Yes, take it as it is
Okay.
first before you put it down, before you derive it, because otherwise people will get confused. Yes, that's where mistake
Okay.
come from, is confusion.
All right, thank you. I'll do it here. Can I do this? Then I'll do what you are suggesting so that you can understand. I'll
Yes.
rewrite it, then derive it to make it
Yes,
easy.
yes. Yes, so now can be
Yes.
straightforward.
All right,
Calculate the
thank you.
process. Thank you.
Okay. So now we're gonna maximum and minimum turning points. So a turning point is a stationary point. Please mute your mic. Okay. All right. So I am going to explain this. Tobani, I saw your hand. Can I please explain this? And then you'll ask the questions after when I'm done so that it can make sense. So every time they say a turning point, it's either they say turning point or a stationary point. Reason being, now we are talking about the graph that has two turning points. We are used to a graph that has one turning point. Maybe it looks something like this, or it's facing down. So now we are focusing, we're gonna be doing the graph that can turn 2 times. So this one is your minimum turning point. This one is your maximum turning point. So the turning point, they call it also a stationary point. If you did pure maths, you'll understand that this is what we call a cubic graph. A cubic graph has two turning points. So these 2 points, they call them the stationary points. It's a turning point. Turning points, the minimum and the maximum. So for you to calculate the turning point of a function, you have to derive it for the first time. So if you remember for the quadratic graph that we had a formula. But when coming to this one now, for us to get the turning point, we have to derive it and then solve for x. You'll see the steps as I do them. And then the maximum turning point is the second derivative of your function. And then if your second derivative of a function, the answer is negative, then we say it's a maximum point, turning point. And then if the answer for the minimum, the answer is positive, then we're going to say that your turning point is the minimum. So it means that my answer, if I get a positive answer, it means that that turning point is supposed to be here. If I get a negative, then it's supposed to be here. I hope I wrote the right thing here. Maximum turning point, the answer is less than 0. Minimum, it's positive. Okay, I hope I wrote the right thing. I don't know if anyone has the notes. Hopefully I'm right. Negative, yes, max. All right, yeah, it is correct. And then they're saying to determine whether the turning points are minimum or maximum points, you substitute the x value into the second derivative. Again, I'm going to show you what I mean by these notes, because when they're like this, they don't make sense. But I think with the calculations, you'll be able to make sense. So let's look at the example so that we can apply whatever I wrote here. And they're saying that find the turning point of the curve y is equals to, so this is your function. So we need to find the turning points. And I said that when you find the turning point, you must first derive. You find the derivative. All right. So now let's do that. And then here I said that, remember that to solve for x, if you don't factorize, this is the formula. We use this formula, the quadratic formula. So I am choosing to use this formula to solve for x, because for me to find my turning points, I am first going to derive, and then after I derive, I take my answer and equate it to 0. Let me do it so that you can understand what I'm talking about. So we're gonna derive first. So firstly, we need to find the dy over dx first. So dy over dx, so that can make sense. So we're gonna derive first. So the derivative of my y with respect to x is going to be equals to, you derive the negative 3x. Oh, let me just try to do it again, piece. But you should know how to do this by now. Let me write it here again. If you are given y is equals to x to the power of n, when you derive it, the derivative of this will be n, then x to the power of n minus 1. I'm doing this because I don't want to do this long step again. I'm writing this formula again so that you understand. So when you derive, you do it for the negative 3x cubed. You do it for 9x squared. You do it for negative 24x. You also do it for 26. You derive each and every one of these numbers. So this will be the derivative of is going to be negative 3 and then x to the power of 3 minus 1. Let me just do it the longest way so that you understand. So this will be the derivative of y over dx is going to be, according to what I wrote here, is going to be negative 3, then x to the power of 3, then plus, this one will be 9 times 2, and then x to the power of, this is 3 minus 1. Then this will be x to the power of 2 minus 1, and then close bracket, and then this will be a minus, then 24 times 1, then x to the power of 1 minus 1, because there's always a 1 here. There's always a 1, even if you don't write it, there's a 1 here on this x. There's a 1 here every time. And then we are going to have, then this is plus 0. The derivative of a constant is 0. Derivative of a constant is 0. This is 3 minus 1, 9 times 2, then 2 minus 1, and then this is 1 minus 1. I hope that will make sense. I'm doing what I did here. And then this will be negative 3x squared, and then plus 18 x, and then minus 24 x to the power of 0. X to the power of 0 is 1. X to the power of 0 is 1. This will be negative 3x squared plus 18x minus 24. X to the power of 0 is 1. 1 times 24 is 24. Now I have my derivative. Then, therefore, when you are looking for the turning point, they are saying that you must take the derivative of your y and equate it to 0. What is the derivative of y? This is my derivative of y. dy over dx is equals to this. So I'm going to substitute. Then this will be negative 3x squared plus 18x minus 24 is equals to 0. And then someone once asked, when do we use this formula of a quadratic formula? We use it when you want to solve for a variable, either q, p, or x, because there's a square here. This square allows us to use this formula. So we are going to use this formula to solve for that x. So when I use this formula, my a, when I use this formula, my a is negative 3. Let me write it here. My a is negative 3. My b is 18. And then my c is negative 24. I see someone's hand. Do you want to correct me?
Hello, ma'am. How are you?
Yes, I'm good, and you?
I'm fine. I'm lost here. Can you please assist me? Where did you get the 18? Because I can see this
What
one.
is 9 times 2? What is 9 times 2?
Oh, okay. 18. Oh, okay. You multiply the ones that are inside the brackets.
Yeah, I'm applying the rule that I talked about. I just explained this here. I said that you use this rule. If there's a number next to your x, this is the number k. You say n times k. That's what I did here. I had 9x to the power of 2. When I derive, I'm going to say 9 times 2, and then 2 minus 1. All right?
Okay, no, it's fine. Thank you.
Askis, you'll watch the video again. So you must watch the first lesson. This will make sense. So here we substitute. Yes, just watch the first lesson, then you'll be fine. Don't worry. So the formula is the formula is negative b. Then this is the square root of b squared minus 4ac. Then I need to solve for x because it's a x squared. So I'm going to use the quadratic formula. Then this will be x, and then my b is 18. So this will be minus. Then I replace b with 18 plus or minus. Then the square root of my b is 18 all squared. Then minus 4. Then my a is negative 3. And then my c is negative 24. And then everything is over to a. So I'm going to have two answers. The other answer, you use this plus. The other answer, you say minus.
2 multiplied by negative 3.
Thank you. 2 multiplied by negative 3.
Why?
Okay.
Thank you.
-3.
Thank you. Give me the two answers, please. So this is plus or minus. You have two answers. Why? Because of there's a plus and a minus here. You say negative 18 plus whatever this, my negative 18 minus. Yes, give me the answer.
2 and 4.
My answers are 2. Is it negative 2?
Negative
Okay.
Negative 2.
No. X is either 2 or 4.
Negative 2.
Okay, let me use my calculator because now you give me
2
two
and 4, yeah,
answers.
bro.
2 and
Positive
4.
2 and positive 4.
They are both
Okay.
positive, ma'am.
Is the 2 is positive?
Yes.
Yeah, they're both positive.
Yes.
Okay. But someone
The
said
2 is
negative.
positive.
It's positive.
Yes.
Okay.
Yes. Even the 4 is positive.
Correct.
Okay. All right. So this will be positive 2 or my x
Positive.
will be positive 4. All right. So I have the x values of my turning point. Now I need the y values because remember, when you're looking at the turning points, there are two values. If this is your graph, this is y and this is x. You must have two values. So we have we have a 2. So let's say this is our 2 and then this is our 4. So it means we are missing these values. We are looking for the y. We are looking for the y because we are looking for the turning point. We're not doing the minimum and maximum. We're just looking for the points. So now I am going to have, I'm going to use this original formula to substitute. Okay, I'm sorry, my thingy from here, you go here. Or let me do it down here because I don't have a space. Okay, yeah, I can just do it here. It's fine. So now I'm going to substitute. I'm going to use y is equals to negative. Please don't use this, the first derivative. Use the original formula. So this is negative. Yes, then plus 9. So I can just substitute. You use the original, please. You substitute into the original. So this is minus. I'm using this one of 2. So it's going to be y is equals to negative. Then we said my x is 2. So this will be 2 to the power of 3, then plus 9, and then 2 to the power of 2, and then minus 24, then times 2, then plus 26. I am using 2 to look for the y of this 2. I am using this 2. Someone please help me with the calculator.
Your
It's
y is
18,
going to
ma'am.
be 6.
Is what? 18.
Yes, I've got 18 on my side.
Okay.
6.
I got
6.
6.
6 on my
You got 6.
Positive 6. Yes.
Okay, guys, please. 6.
But you can
Okay.
double check.
6.
Yes, it's 6.
Okay. So this is the point of the where the graph is going to
that's 6.
turn. Thank you. So our graph is going to turn here. And then now we look for the y of this 4. That's where our graph is going to turn at these 2 points. This will be y is equals to negative. Please, you always use the original. This is 4. Okay, we'll just do this. The cube plus 9 square minus 24. Sorry. Minus 24 bracket, then plus 26. So we put 4 here now. 4. You always put into the original. And then what is the answer for this one?
10.
It's 10.
Yes.
Yes.
Okay. So it means that my points will be 4 and 10. 4. This is where my graph is going to 10 and 10. Remember, the question said find the turning points of the curve. So these are the turning points. 2 and 6, 4 and 10. Again, remember, you're not going to be asked to plot the graph. The most important thing is to know that step number 1, when you're looking for the turning point, you find the derivative, you equate it to 0, solve for x, substitute your x into the original. That's what you must know. Step number 1, you derive. Let me just try to write it here. So first, you find the first derivative, then equate it to 0. Step number 2, solve for x. And then step number 3, then substitute subs x into f of x, not f prime x, f of x. There's a difference between f of x and f prime x. Please, this is the derivative. The derivative, this one is the original. This is the original function. Original function. Those are the three steps that you do. Step number 1, you derive, then equate it to 0. Step number 2, you solve for x. So I did it here. So this is my step number 1. Please mute your mic. This was step number 1. Step 1. And then this one was step number 2. And then what I did here is step number 3. I derived, equated to 0, and then I solved for x. And then after solving for x, I substituted my x values into this original. My original was y is equals to negative x to the power of 3 plus 9x squared. Yes, I see a hand. I see a hand.
Hi, ma'am. Can I please ask a very blunt question? Why would we substitute the known values to the original equation, whereas we got the values from the derivative?
Remember, when you're drawing your function, you draw the function using the original. For when you're drawing the graph, you're going to use the original function, right? You don't use this one. You don't use the derivative. Yes, you use the original to draw the graph. So whatever value you put on your x must give me a value on the graph. So if you're going to put for the second derivative, it's not going to give you the value on this graph because we're drawing the graph. We are drawing the graph of this function, the original function, not the derivative, because the derivative of this function, these two graphs are not going to be the same. This is a quadratic. You see, it's x squared. This is a cubic. It's x to the power of 3. So it's going to be two turning points. Yes, I see Zandamela.
Yes, ma'am. So
Yes.
the statement that says substitute x value into second derivatives, where does it apply?
What are they saying here? Yeah, can you please read it for me here? What's written here?
To determine whether the turning points are minimum or maximum points, substitute x value into the second derivative.
Yes, to determine whether the turning points are minimum or
okay.
yes. So here we are looking for those turning points. Now, if you want to see if it's a minimum or a maximum, you substitute the x values into the second derivative. Now let's see what I mean. Let's go to number B. That's the following question. Determine which point is a maximum and minimum by using what? Second derivative. So for me to determine the minimum and the maximum, it means that I must first find my second derivative. I have my first. Remember they told me to write the first derivative. Let me write the first and the second. So my first my original, I have y is equals to negative x to the power of 3 plus 9x squared minus 24x plus 26. My first derivative, when I did it previously, I got, let me just do, I'm going to use 1 prime. Ne? I said y prime, even if you say dy dx, or let me say dy dx for consistency. Dy over dx, I have a negative 3x squared plus, so this is the first derivative, plus 18x minus 24. So now for me to determine which point is maximum or minimum, first thing I need to find the second derivative. So meaning I'm looking for the d squared. So I'm going to look for d squared. Sorry, then this is a square. So I am deriving this one. Second derivative, I am taking this, I am putting it here. So this will be 3. I'm going to use that rule again. It's 3. And then x to the power of 2 minus. So why am I saying 3? It is 3. It's 3 times 2. And then I have x.
Negative 3, ma'am.
Negative. Yes, it's negative 3. Yes, thank you. Then this is x. And then this is 2 minus 1. I'm doing it the longest way again so that you understand. And then plus, I am deriving this one of 18 now. So this will be 18. Remember I said that there's a 1 here. There's a 1 there. So it's going to be times 1. 18 times 1. And then x to the power of 1 minus 1. This one minus 1. And then we said that the derivative of a constant is 0. This will be 0. Derivative of a number is 0. Now let's write the answer. So my answer is going to be negative 3 times 2. It's negative 6 x to the power of 1. You don't need to write the 1. And then plus 18 times 1 is 18. Then x to the power of 0. Any number to the power of 0 is 1. So this will be plus 18 because 18 times 1 it's just 1. And then now we found our second derivative. If you remember, we said that here it says to determine whether the turning points are maximum or minimum points, substitute the x value into a second derivative. So we're going to substitute our x value. Which x values? The ones that we got. We got these x values. These are our x values that we got. We're going to take these x values. Our x values are from the turning point. Ne? X is equals to 2 and x is equals to 4. So now we can substitute y into your second derivative. This is your second derivative. You can either say y prime prime or dx over this doesn't matter. Dx or f of x doesn't really matter. Then now we are going to substitute. So we are going to have, this will be negative. What are we going to have? For this one, we are going to have negative 6. Then you put 2 here. Plus 18. And then we're going to get our answer. So let me just say y prime prime. What is our answer here?
6. 6.
Sorry,
Okay.
ma'am.
6.
Ma'am?
6.
And then
Did
this
you
one?
say
Didn't you say 18 is
-6.
1?
I said
Negative
x to the power of 0 is 1. Then 1 times 18 is 18.
Okay.
Is this there's a 1, okay, times 1. Then the final answer will be 6x plus 18.
Okay. Okay.
Is it
Thank
fine?
you. Thank you.
All right. Okay. And then, so this one will be negative 6 times 4 and then plus 18. So this will be what?
Negative 6.
Negative?
6. Negative 6.
Negative 6. So now the question is this one less than or greater than 0? This one, 6.
Greater than 0.
Greater than 0.
6 is greater than 0. So if it's greater than 0, what does it mean?
It's the maximum.
It's a minimum or maximum.
It's a minimum
It's
point.
minimum. Hey, it's minimum.
Oh, yes, it's a minimum.
It's minimum. So you're going to
Which means
say,
the minimum,
yeah, so this is the minimum turning point.
a minimum turning point.
Yes, turning point. And then this one, is it greater or less than?
It's less than 0.
Less than 0.
Less than 0. So it means it's what?
It's a
Maximum.
Maximum.
Yes. So the whole
Minimum, the
point.
minimum turning point.
No, but let's go back to the nodes. We have the nodes most. Check the nodes. Let me go back. Let me check the nodes so that we don't fight. Okay, let me see my study guide. Okay, study guide says, okay, just maximize it so that we are all fine. The nodes. Okay, here it is. You see, the study guide says that the second derivative, if your answer is less than 0, then it's a maximum. Can you see? Maximum. If your answer is greater than, then it's minimum turning point. I hope that we can put it to rest now. If your answer is greater than 0, minimum, less than 0, maximum. That's it. And then now, so this answers, someone asked me a question about the maximum and minimum. I think now we are fine. And please practice with your activities, it will make sense. The whole point of this, we're going to maximize and minimize profit and costs. As long as you know how to calculate, then when you move to application, you'll be fine. This is just the basics. We're going to go to application. Application will make more sense. Now we are determining, they're saying determining intervals along which a curve increase or decrease. All right?
Sorry.
So with this one, yes.
Can I disrupt? Can we go back to the previous?
Is it this one?
I think I'm in a sticky situation here because my equation that I was working with, it is x squared minus 6x plus 8.
Wait.
Instead of 3x squared plus 18x minus 24.
What is the original formula? What is your the function? What is the original function?
I think, ma'am,
Yes, you said you think?
I think this one, he just divide by -3 both to 18 and 24. That's why he got x squared minus 6x plus 8.
Yeah, but I'm not getting
You can't divide
6
by
and
8.
-6.
My question is, he can't. It's not allowed. You can't divide this by 3. It's not allowed. You can't.
Why not?
It's not an equation. It's an expression. If this was equals to 0, if we were solving for x, then you can. If this was negative 3x squared plus 18x minus 24 equals to 0, you are allowed to divide. But if I give you y is equals to, it's an expression, this one is an equation, this is just an expression. Negative x this plus 18x minus 24. You can't divide by 3. It means you'll have to also divide y by 3.
So you have to leave it as cumbersome as it is.
Yes, we are not solving. If you are given an equation like this with an equal sign equals to 0, you solve. You see here, when I was using the quadratic here, it's because you see, this is an equation. Remember, I derived. Okay, I think maybe the confusion is here. Remember, this is a derivative, right?
Mm.
Then the first step says that take your derivative and equate it to 0. That's what we do. I equated it to 0 because I was solving for x. You can't equate it to 0 if you're not solving for x.
But this is the thing, though. When, in order to get x, is equals to 2, when x is equals to 4, that's exactly what I did. That was my formula, my basic formula.
Equation, yes, that's your equation. Yes.
So everybody else was working with negative 3x squared plus 18x minus 24. I was working with x squared minus 6x plus 8.
Why?
I mean, there you have the equal 0. I mean.
Okay, fine. Let's do that. Let's see. No, it's fine. Let's see. So you can't listen. You cannot divide by 3. This is not your first derivative. This is your first derivative. The rule says that when you have to do, okay, let's derive it. Derive it from the beginning. This is the first derivative. Do you agree that this is the first derivative? This one, right? This is the first derivative. Yes. And then here it says that to determine whether turning points are minimum or maximum, substitute your x values into the second derivative. So it means that for me to answer number B, I must look for my second derivative. So when you're looking for the second derivative, you find the first derivative. This is us finding the first derivative. First derivative, and then you find the second derivative. Find the first derivative, and then find the second derivative, and then use your second derivative to determine the minimum and the maximum turning point. Follow the rules. Find the first derivative, and then find the second derivative. Forget about this one.
Always my
Let this one rest,
That
because
makes
here, this is
sense.
A. This is A. We found our x values of our graph, where the graph is going to turn. Fine, I have the x values. My graph is going to turn at 2 and 4. I'm done. I'm going to number B. Question of number B says, determine which point is maximum and minimum by using the second. This is another question, right? By using the second derivative. And then it says here, to determine whether turning points are minimum or maximum points, substitute the x values into the second derivative. X values of what? Of the turning point. It to the second derivative. So I'm saying to you, take this. Y is equals to negative x cubed plus 9x squared minus 2x plus 26 and derive it 2 times. So are you telling me that when you are deriving for the first time and the second time, after you derive for the first time, you divide it by 3? That's my question. And when did I divide here when I was deriving? Have I ever divided here when I was deriving? This one, I didn't divide. When I was doing number B, I didn't divide. I just derived. We want you to derive. And then after you derive, take your x values of that turning point and put them into the answer of your second derivative. That's what we're looking for. We cannot take this equation. Derivative is not an equation, it's an expression. All these are expressions, unless I say equate it to 0 and solve for x.
Okay.
Is it fine?
Cool. Sharp.
Ask easy, but please practice. Just look at the activity and then try to do it and see. It will make sense. Which practice is gonna make sense? One lesson doesn't make sense. And please don't forget to talk to the Agent Academics. If you are struggling, they can assist. They will try and assist. So please do Don't just let it rest because it's gonna be a problem. Now after this, I have to move
No,
on
it's
to
not so much of a
application.
struggle. It's more of understanding that a derivative, I have to use those cumbersome numbers. But it's fine. Bophile ke A, sharp. That's all I
Okay. So, all right.
Ma'am,
Now we
sorry.
determining, yes.
Before you continue, I just wanted to ask Uri if maybe you have recommendations of like videos where they explain derivatives because I am struggling. Yo,
Yeah, it's
I know,
tough.
man.
I think we can just go to Google and you just yeah, not Google, go to YouTube, sorry. Go to YouTube and just search differentiation. Like just say basics or something. Just YouTube is gonna give you something. Because you
Okay,
really need
thank
to
you, ma'am.
practice. Yes, just go to YouTube and say differentiation for beginners, maybe. If you say for beginners, it will make sense.
And another thing, ma'am, I think you can also go to any student, a matric student, and ask. They are doing this.
Yes, they're
Yes.
doing derivative, yes. Those who
Yes.
are done with
And
matric.
not everything is.
Yes,
Yeah.
those who are done with matric, not those who are doing matric because they haven't done calculus yet.
Yeah, maybe. Yeah, they haven't done it because it's
Yes,
still
they
March.
haven't.
Yeah, they
Yeah.
haven't. But surely
But
they
your
are gonna have.
agent academics are also there. Please do send them emails to assist. They will try something. They're there to assist you. Like honestly, if you are struggling with the basics, then they're gonna help you with that. Then everything here it will make sense. Because I'm just giving you these basics so that I can go to a now application into economics so that it can make sense. I know there's a lot of maths, but with practice you'll get it.
Do they assist for free?
Yes. Yes, they're like your e-tutors. Yes, they assist for free. No need to pay. Just, yes, please do. Make an appointment to send them emails. They will assist. They'll find a
Face
way
to
of
face.
assisting. During the day though, not, yeah, late. During the day, so please
But ma'am,
do.
do they assist face to face or maybe it's only on it's also on Teams?
They assist where?
Face to face, so it's also on Teams.
It's also on Teams. I don't know about Facebook. You
How
have
are you
to
going
email
to
them.
get them face to face, but everything is
Exactly.
on Teams, yeah.
Yes.
Hey, my
So
sister, I'm with you. I can't even ask questions because, hey, kumnyama
yeah, I
too.
know
But we are here.
it's yeah. Let's
We are
just
dying.
let's just be here. I'm sorry. Okay, let me do the last one. I'm so sorry. Okay.
And
So
Sham, I like your spirit here, just giving us explanations and then you pass. Ah,
yeah,
we can't
what
even hold you not to pass to the next one.
because yeah,
Simply
because
because
it
we
does
can't
doesn't
make sense.
understand the first one.
yes, I know.
Everything.
Trust me, I understand. Calculus is calculus. It's just yeah, but we'll get there. I'm
And
going
it's
to
not
do it again with application. I think when I do application,
It's not
somewhere,
hard,
somehow
man.
you get it.
difficult, this one.
Yeah, it's not, man. You're
Yeah, for
making
people who
sense.
did pure maths, I know it's for
No,
you
it
guys,
isn't
it's easy.
difficult.
It's not,
Yeah.
man.
It's not
Just
this one.
they say
Guys,
practice
just
makes
because you
perfect.
understand it, you can't say it's not difficult. Please, please bear with us. Please.
Yeah, guys, let's be
Let's
patient.
respect each other's understanding here. Kancane kancane.
Yeah, okay. So let me do the last one so that yeah, we're done for the day. Uh, so this function that we've been doing, it's a cubic function. The graph looks like this, but you'll see it somewhere there in your notes, in your study guide. The graph has two turning points. It looks something like this. This is your y, and then this is your x. So this is the turning point, this is another turning point. So because we are not going to be asked to draw the graph, I think it's easy for you. So with this one now, so we have what we call increasing and decreasing. So when you move, in maths, when you move from left to right, and the line, let's say when you measure whether the graph is increasing or decreasing, you must always move from left to right. So when I start moving this cursor from here to here, you'll see that this line here is decreasing between these two. This line goes down. This is decreasing. And then when I start moving from here, and then I go up, this is increasing. Because when I move from left to right, this line is going up. We say it's increasing. And then again, when I move from here going down, it's decreasing. So that's how we measure. We say the graph is increasing or decreasing. You move from left to right every time. You start moving from here to here. When the line goes down, it means it's decreasing. When it starts going up, it's increasing. So from here to here, it's decreasing. From there to there, it's increasing. So here they're looking for the interval. We are looking for these 2 points here. We want these two, where your graph is increasing and decreasing, sorry, where it's decreasing, and then where does it start increasing? That's what we mean here by saying intervals along which a curve increases or decreases. So I'm going to show you with calculations, how do we determine the interval? The interval is two numbers. Again, if I have a graph, I'm going to use one curve. If I have a graph, and then my graph looks something like this, and then this is the turning point. At the turning point, that's when my graph starts either increasing or decreasing. And I said, you must always start moving from left to right. So if I was to ask you to give me the interval, 2 points where my graph is increasing or decreasing, you'll notice that from here to here, this graph is increasing. When I start moving from left to right, it goes up. So meaning it's increasing. And then at the turning point now, when I start moving from here going down, this side is decreasing. Because for us to see whether the graph is increasing or decreasing, we move from left to right. You take your ruler and you move from left to right. Moving from here to there, you'll see that the graph is increasing. And then from the turning point, it starts dropping. That's what we call decreasing. So we are looking for the interval. So normally I say, I used to say to the learners, these two parts, my graph is decreasing here. So when I move from here to here, so it's from here to here, it's decreasing. Then from there to there, my graph, so it's increasing, and then this one is decreasing. So I would say that this side, I say x is less than. If this point here is 1, let's say my point is 1 here, the turning point, here it's 1, and then maybe here it's 5. When I want to say the graph is increasing, I'm going to say my graph is increasing 1, x is less than 1. Why am I saying negative? X is less than 1. My graph is increasing. And then from here, going to the right, I'm going to say x is greater. So meaning that the values from 1 going there, they are more than 1. So it's greater. Starting from 1 going to the right, we say greater. Starting from 1 going to the left, we say less than. So I say x is less than, then x is greater than. My graph is increasing. X is less than. My graph is decreasing from x from 1 going to the positive side. And then if I have to write it as an interval, we are going to say this will be negative infinity from the negative side until 1. And then this side, we are going to say from 1 until positive infinity. That's how we write the interval. This is a positive infinity, this is a negative infinity. Negative infinity is always on your left. Positive infinity is always on your right. Again, I know it doesn't make sense, but it will make sense when we do calculations. Okay, so now let's look at the calculation part. So I was just doing the graph part. The calculation part, they're saying that when we have to determine this, the first thing you need to do is to find your first derivative, solve for x, and then second derivative. What am I saying here? To determine the interval. Okay, so we're going to find our first derivative. Hope I'm right here. Yes, please mute your mic. So it means you must find the turning point again. So this will be the first derivative. So using the same thing again. First derivative My first derivative is going to be 2x, then 2 minus 1 is 1, then minus 20. Yes, I see the hand there. The hand. Okay. So when we derive this, the derivative of 120 is 0. Okay, let me just write everything here because now it's going to be a problem. This is 0. Then my answer is going to be 2x then minus 20 because x to the power of 0 is 1. So this is the derivative, first derivative. And then the second derivative is going to be d squared. D squared y. So I am going to take this. So this will be 2x. I hope that's fine. Yes, I see the hand. Okay, let me write it again. I see the hand. You can ask your question. Eh? There's always a one here.
Am I the only one who's late for the next class, guys?
Yes.
Oh, you
You're
mean the
late, dear.
FAC?
You late for the next class? Okay.
Yes.
Oh, there's a next class.
Yes, financial
Yes, ma'am.
accounting.
Oh, okay. Let me finish. Okay, so this will be. What am I doing here?
Next class for what?
This is 2. I think there's a next class. Next class for what, guys?
Financial accounting, ma'am.
Oh,
Financial
yes.
accounting.
Okay. Oh, okay. Let me finish. I'm done. All right. So now they're saying here, if the answer that you're supposed to substitute, but because we're substituting the second derivative. So our second derivative doesn't have x, né? So we're just gonna have 2 here. So the question is, so it means that my turning point, my graph is going to turn here at 2. So it means this will be 2. So the interval, you write these two numbers. You just write it like this. So you will have negative infinity, and then these 2. And then we have, what is it? 2. Why am I writing 1? 2. Then we have 2 and positive infinity. So obviously this one is increasing, and this one is decreasing. That's it. Just do this. Just that now my question doesn't have a part where I'm going to substitute. This one increase, this one decreases. Yeah, but it's rare for this. I don't know. I've never seen this question. Do you have this question in your assignment? No. Okay.
No,
You
we don't.
you don't,
No,
ne?
ma'am.
No, we don't.
It
Yeah.
only ends here, ne? It only ends with, I think, I'm not sure though. Because this is like pure maths here. We're going for pure maths now. Yeah. So this is where the graph. So your turning point, actually the point that you get at your turning point, then you just write these two things. Then that's a decrease, increase, decrease, increase. There's nothing much here. I haven't seen anything here. Nothing. That's it. Guys, that's it. Let me stop this recording. Yes, Ndaveni? Because
It's
there's another
financial
class.
accounting 1501 or 1502.
Is that a question for
No.
us? Guys?
No, ma'am. There is a question for me. Sorry, ma'am.
Oh, yes. Hey, I'm going to stop
uh,
the recording. It's too long because there's nothing else to do. Yes, you can ask. Sorry, you can ask.
I just wanted to ask, ma'am, are there any DSC 1520 modules?